Good day, guys. Welcome to this class. I believe you are enjoying our classes, and please, if you have not subscribed to our channel, please subscribe to the channel. Click on the notification bell, give us a like, give us a positive comment, so that whenever we upload a new video, YouTube will notify you. This is Normal Science Tutors Online, and this is your online video class. Alright, so for the class for today, we are going to be discussing nuclear energy. Okay, so we are going to be looking at nuclear energy, and then we'll look at some of the uses. We'll also look at nuclear fusion and fission, and some of the uses and importance of nuclear energy. All right, so guys, get your writing materials ready so that we can go to the class for today. Okay, so if you are ready, please let us go. Alright, so as I said, we are looking at nuclear energy, and actually you cannot discuss nuclear energy without looking at the configuration of the atom. Alright, so if you look at the atom, which is what we have been discussing in some of our lectures so far, up to now, we see that in the in the atom, you have the central nucleus, which consists of the protons and the neutrons. Then you have the electrons surrounding the nucleus. All right, now the protons and the neutrons, they are called the nucleon of the atom. All right, so the energy that is required to separate the proton and the neutron in an atom is called binding energy. Okay, so binding energy is energy released to join or fuse together the nucleon of the nucleus. So the nucleon of the nucleus is the proton and the neutron. So that energy that is used to fuse together the neutron and the proton is called binding energy. Now, okay, so when the nucleus of an atom is separated, the combined mass of proton and neutron when added together is more than the mass of the nucleus as a unit. Okay, so the difference in mass is called mass defect. Mass defect is sum of masses of proton and neutron, or the mass of the nucleus. That is mass defect. Okay, so mass difference is the sum of the mass of the proton and the neutron. And this mass defect is related to Houston equation. You know, this is Houston equation, right? Okay, Houston equation says that energy is equals to mass times speed of light raised to power 2. Okay, so E is energy, change in mass, and then C is speed of light. Okay, so this is briefly introduction to nuclear energy, and we're going to be discussing more on nuclear energy. All right, so we're looking at nuclear fission and nuclear fusion. Nuclear fusion. Nuclear fusion is a phenomenon or reaction where two or more light nuclei combine together to give you a heavier nucleus with large amount of energy. So in this example here, you have two isotopes of hydrogen combining together. Okay, so you have deuterium and tritium combining together to give you a helium which is an alpha particle, and it is heavier than these two light particles. Then with the release of a neutron and then a large amount of energy. So this is an example of nuclear fusion, joining together, right? So then you have what is called nuclear fission. Nuclear fission is the breaking up of the nucleus of a heavy element into nearly two equal halves with release of large amount of energy. So this one is like decay. Okay, this is like decay of a substance or disintegration. So nuclear fission is the disintegration of the nucleus of a heavy element into nearly two equal parts. Okay, like here uranium. uranium will decay or disintegrate the presence of a neutron to give you barium and krypton with the release of 3 neutrons. Okay, all right. So this is an example of nuclear fusion and nuclear fission. Well, the other topic we're going to look at is the other chain reaction. Okay, so chain reaction is a multiplying and self-sustaining reaction. An example is in the bombardment of uranium. Uranium is 25. Uranium is 25. So in the bombardment of uranium 235 by a neutron, just the example we saw now, several neutrons are produced as byproducts. These neutrons may cause the splitting of other uranium nuclei, which in turn yield more neutrons, which may further split other uranium nuclei, and so on. So this form of reaction is called chain reaction. Okay, so it's a multiplying reaction and it's self-sustaining, and it can continue for as long as uranium remains and large amount of energy is released in the process. Now, this is actually the type of reaction that is used in nuclear reaction to generate. So when you talk about nuclear energy or all those nuclear warfare and all that, that's how the reaction, the reaction multiplies itself. Okay, that's why nuclear reactions are always very disastrous and catastrophic. So like the atomic bomb that was released in Hiroshima some years back, was, if you read about that story, you will see that it had a multiplying effect and it caused a lot of destruction back then. And even the effect today, the people from that region, they still suffer from the effect of a release of that atomic bomb back then, years ago. Okay, so what are some of the advantages and disadvantages of fusion, or advantages of fusion over fission? Fusion is more easily achieved with lightest elements such as hydrogen. We saw it just now in our previous discussion. The raw material required for fusion are more cheaply and readily available. Okay, it's like hydrogen, you can get it from electrolysis of seawater, which is cheap. The fusion process produces less dangerous byproducts. Okay, then there is no upper limit to the mass of hydrogen that can be exploded in a nuclear fusion process. So these are some of the advantages of fusion over fission, and I just want you to take note of them. Then what we are going to look at is the peaceful use of nuclear energy. Okay, so what are the gains of nuclear energy? One of the gain is that nuclear energy is used for generating cheap electricity. Okay, it's used for generating cheap electricity. The product of nuclear fission are used for radiotherapy. Yes, then radioisotopes are used in agriculture as tracers and preservatives. Some spacecraft and ships are now powered by nuclear energy. And this is where the world is actually going to, the use of nuclear energy. Okay, so Nigerian nuclear energy program. Now, because of the importance of nuclear energy, Nigeria as a body, Nigerian Nuclear Regulatory Authority was formed, and to help in carrying out research so that Nigeria can begin to generate electricity from nuclear sources. Okay, and if this is done, it will help in the development of health, agriculture, industries, science, and technology. All right. So, but what are some of the challenges that Nigeria faced in developing their nuclear energy program? One of them is the handling of radioactive materials. We don't really have means of handling them, so there's a great concern on the safety and security of radioactive sources. So, if radioactive sources are not properly handled, they can lead to disastrous effect. Yes, they can actually cause a lot of problems to individuals and handle them, so they need to be properly handled. Also, there's lack of dedicated storage facilities and detection capacity at point of entry. We don't have all this. So these are some of the problems that are affecting development of nuclear programs in Nigeria. Another one is inadequately trained staff and inadequate tracing of sources. So these three are some of the major problems that has actually affected the development of nuclear energy in Nigeria. Okay, so guys, thank you so much. This is a short class, and thank you for your time. And this way, we are stopping this particular class. Okay, so we are hanging it here, and in our next class, I hope to see you. But before then, please try and subscribe to our channel. If you are just visiting this channel is all about physics, and we are here to help you. So if you are just visiting, if you check the channel, you will see a lot of, we started from the very scratch of physics, and here we are so far. God has helped us, and here we are, and we are really happy that we've gone this far. We are almost covering the curriculum of physics, so we are really glad, and thank you for those who will be following us. Please help us to share, subscribe to our channel, give us a like, click on the notification bell so that when we upload a new video like this, YouTube will notify you. So this is Normal Science Tutors Online. We remain your online tutor. Thank you for being with us so far. Thank you for staying with us, right? Reach us through the WhatsApp number that is showing right on your screen, and we'll help you out in any area that you need our assistance. Thank you and have a nice day.